The question nobody asks. I want you to try something right now. Hold up your hand. Move it around. You can move it left. You can move it right. That's one dimension. You can move it forward. You can move it backward. That's 2 dimensions. You can move it up. You can move it down. That's 3 dimensions. Now try to move it in a 4th direction. A direction that's not left, right, not forward, backward, not up, down. A completely new direction. You can't. And here's the thing that should bother you. Why can't you? What's stopping you? Who decided 3 was enough? This isn't a silly question. This is one of the deepest questions in all of physics. And I'll tell you something. Most physicists don't have a good answer. They'll give you mathematics. They'll give you equations. But ask them why 3 dimensions, and they'll shrug. I don't like shrugging. I like answers. So let me take you through this. Let me show you what we actually know about dimensional space. And let me show you why 3 might not be a coincidence at all. What dimensions actually mean. First, let's get clear on what a dimension actually is. And I don't mean the dictionary definition. I mean the physics definition. A dimension is a degree of freedom. A direction you can move independently of other directions. Think about a train on a track. That train can only move forward or backward. 1 degree of freedom. 1 dimension. It lives in a 1-dimensional world. Now think about an ant on a table. That ant can move forward, backward, and left, right. 2 degrees of freedom. 2 dimensions. A flat world. Now think about a bird. Forward, backward. Left, right. Up, down. 3 degrees of freedom. 3 dimensions. Our world. Simple enough, right? But here's the thing. Mathematics doesn't stop at 3. I can write equations for 4 dimensions, 5 dimensions, 100 dimensions, 1,000,000 dimensions. The math works perfectly fine. So if 4 dimensions are mathematically consistent, why don't we live in 4 dimensions? This is where it gets interesting. The anthropic hint. Now I'm going to tell you something that some physicists hate. Something that sounds almost religious. But it's not. It's pure physics. We live in 3 dimensions because we have to live in 3 dimensions. In any other number of dimensions, we couldn't exist. Let me show you what I mean. Start with 2 dimensions. A flat world. No up and down. Just a sheet of existence. Now try to build a creature in 2 dimensions. Give it a digestive system, a tube running through its body to process food. See the problem? That tube would cut the creature in half. There's no way around it. In 2 dimensions, a digestive tract splits you into 2 separate pieces. You'd fall apart, but that's just biology, you might say. What about physics? Here's the physics problem with 2 dimensions. Imagine the Earth orbiting the Sun in a 2-dimensional universe. In our universe, gravity falls off with the square of the distance. Double your distance from the Sun, gravity drops to 1/4. But in 2 dimensions, gravity would fall off with just the distance. Not the square, just the distance. And here's what that means. Stable orbits become impossible. In 2 dimensions, any tiny nudge, any asteroid, any perturbation would send planets either crashing into stars or flying off into infinity. No stable solar systems, no planets, no us. You following me? 2 dimensions are too few for stable structures, too few for complexity, too few for life. The problem with 4. Now let's go the other way. What about 4 spatial dimensions? This is where I spent a lot of time thinking, because 4 dimensions seem like they should work. More room to move, more possibilities, more freedom. Wrong. 4 dimensions have the opposite problem, and it's devastating. In 4 dimensions, gravity falls off with the cube of the distance. Triple the distance, gravity drops to 1/27th. Sounds minor, right? Just a different exponent. It's not minor. It's catastrophic. In 1917, Paul Ehrenfest, brilliant physicist, friend of Einstein, worked this out. He showed that in 4 or more dimensions, there are no stable orbits. None. Not just difficult. Mathematically impossible. Let me show you why. In 3 dimensions, a planet can orbit a star because there's a balance. The planet's momentum wants to fling it outward. Gravity pulls it inward. These 2 forces balance at a specific distance, creating a stable orbit. But in 4 dimensions, that balance point doesn't exist. Or rather, it exists, but it's unstable, like balancing a pencil on its tip. The slightest perturbation and the planet either spirals into the star or flies away forever. No stable orbits means no planets circling stars for billions of years. No time for chemistry, no time for life, no time for anything interesting. And it gets worse. Atoms can't exist either. You think orbits are the only problem? Let me show you something deeper. Electrons orbit nuclei. That's what atoms are. Little electrons held in orbit by electromagnetic attraction. In 4 dimensions, the same mathematics applies. Electrons can't maintain stable orbits around nuclei. Atoms would collapse instantly, or electrons would fly off. Either way, no atoms. No atoms means no matter, no chemistry, no molecules. In the 1980s, physicists Max Tegmark and others formalized all of this. They showed that in 4 or more spatial dimensions, the electromagnetic force, the force that holds atoms together, becomes too strong at short distances and too weak at long distances. Chemistry becomes impossible. Complex structures can't form. The universe remains a hot soup of unbound particles forever. Here's what nobody tells you. We're stuck in 3 dimensions, not by accident, but by necessity. What about fewer dimensions? Let me go back to 1 dimension for a moment, just to complete the picture. In 1 dimension, you have a line. That's it. You can move left or right, nothing else. Try to have 2 particles interact in 1 dimension. They can approach each other, they can touch, then what? They can't go around each other, they're stuck. Complexity in 1 dimension is essentially impossible. Things can't pass by other things, everything is blocked. It's like a highway with no lanes, where no one can ever pass. 1 dimension is too restrictive for anything interesting. So we have a pattern here. You following me? 1 dimension, too restrictive. 2 dimensions, no stable atoms, no stable orbits. 3 dimensions, everything works. 4 or more dimensions, no stable atoms, no stable orbits. We're sitting in the 1 configuration that allows complexity, the 1 number of dimensions where physics permits structure, where atoms can exist, where planets can orbit, where life can emerge. Isn't that something? The deeper question. Now I know what you're thinking. Okay, so 3 dimensions work. But why do we have 3 dimensions in the first place? Why not a universe with 4 dimensions where nothing can live? That's a damn good question. And I'll be honest with you, I don't have a complete answer. Nobody does. But let me tell you what I think. 1 possibility is what physicists call the anthropic principle. It goes like this. Maybe there are universes with 2 dimensions, 4 dimensions, 11 dimensions. Maybe they all exist. But we can only find ourselves in a 3-dimensional universe because that's the only kind where observers can exist. It's not that 3 dimensions are special, it's that we're special products of 3 dimensions. Like asking why you were born on Earth instead of the sun. You can only ask the question from places where asking questions is possible. Some people find this unsatisfying. I understand that. It feels like a cheat, like we're not really explaining anything. But here's what I tell my students. The anthropic principle isn't an explanation. It's a constraint. It tells us that whatever the true explanation is, it has to be compatible with our existence. And that's useful information. String theory suggestion. Now there's another possibility, and this one comes from string theory. String theory says the universe actually has 10 dimensions, or 11, depending on who you ask. But only 3 of them are big. The other 6 or 7 are curled up so small we can't see them. Why 3 big ones? String theorists have some ideas. They involve something called brane cosmology, the idea that our universe is a 3-dimensional membrane floating in a higher dimensional space. But here's the honest truth. We don't know why 3 dimensions expanded while the others stayed small. It might be random, it might be necessary, it might be something we haven't thought of yet. I don't like saying I don't know, but I like lying even less. And the truth is we don't fully understand why the universe has 3 large dimensions. What we do understand is that it couldn't have been otherwise. Not if we want atoms. Not if we want stars. Not if we want life. Time, the 4th dimension. Now wait. I can hear you objecting. What about time? Isn't time the 4th dimension? Good. You're paying attention. Time is a dimension, yes, but it's a different kind of dimension. Space and time aren't the same thing. They behave differently. In space, you can move freely in any direction. Forward, backward, left, right, up, down. Your choice. In time, you can only move 1 direction. Forward. Always forward. You can't turn around in time. You can't go backward. You can't even stand still. You're always moving through time whether you like it or not. Einstein showed us that space and time are connected. They're part of a single fabric called space-time. But within that fabric, 3 dimensions are spatial, where you can move freely. And 1 dimension is temporal, where you're forced to move forward. Why 1 time dimension? Why not 2? Because 2 time dimensions would be even more catastrophic than 4 space dimensions. With 2 time dimensions, cause and effect break down. The future affects the past. Prediction becomes meaningless. Physics becomes impossible. 1 time dimension, 3 space dimensions. That's the recipe for a universe that makes sense. That's the recipe for us. The beautiful truth. Here's what I want you to take away from this. You're standing in 3-dimensional space right now. You're surrounded by it, immersed in it. You've been in it your entire life. And that space, those three directions you can move, is not arbitrary. It's not random. It's not some cosmic accident. It's the only configuration that allows you to exist. Every atom in your body depends on three dimensions. The electrons orbiting nuclei, the chemistry that makes your cells work, the stable planet you're standing on, the star that powers your world. All of it requires exactly three dimensions. No more. No less. You're not just living in three-dimensional space. You're a product of three-dimensional space. Your existence is proof that this universe has three dimensions. And three dimensions is evidence that universes like this one can produce things like you. Think about that for a moment. Somewhere in the mathematics of physics, hidden in the equations of force and motion, is a constraint that says three dimensions or nothing interesting. And here you are. Interesting, complex, alive, asking questions about why you have three directions to move instead of four. The universe didn't have to be this way, but if it weren't, you wouldn't be asking. That's not magic. That's not religion. That's physics. And isn't that beautiful?